Hi everyone, this is K1 from ECD section. So today I want to discuss about the spectrum characterization and occupancy of sensing application testing bed. So it is a related to the probability theory and tagiotic process. So coming to the introduction of this section, it is dynamic spectrum access, which is called as a DSA in short form, is a becoming a key enabler for wireless communication technologies. Many DSA concepts such as the citizen broadband radio services and TV white space radio and spectrum database to identify available radio channels. So these are the techniques to find the available radio channels in our surroundings. So and spectrum sensing allows better understanding of actual propagation and actual channel impulse response, allowing spectral database to tune the propagation models to increase the availability of spectrum for secondary access accessed by such spectrum databases, or to increase the availability of local access equalizers as assessed by telecommunication regulations. So these are the channels which are imported settled by the acts license from the telecommunication regulator. So coming to the optimization of spectrum usage, development of new spectrum management techniques going on to address the accelerating demand for more bandwidth by wireless telecommunication operator against the backdrop of spectrum scarcity. So nowadays we need a radio signal which has more bandwidth, so we can transfer much information through it. So these include TV white space and citizen band radio service in 700 frequency range from 700 MHz and to 3.5 GHz band to meet the need for access to more of this lower frequency spectrum. Underlying mechanism that would underpin implementation of dynamic spectrum access, which is known as DSA policy, have been widely investigated. So recently, the IEEE 802.22 working group completed a standard for cognate radio wireless regional area networks, which is known as WRANs, which specifies the medium access control like MAC, physical layer, and policies and procedure for operation in the band that allows spectrum sharing. So these are the uh, organization which trying to uh, improve the wireless communication which having the higher bandwidth according to the presence. So problem statement and proposed statements recording the optimization of signals. So the application of data set generated by a managed network of SCOS, which is known as spectrum characterization and occupancy sensing nodes, is mirrored the most pressing. So these are the terms related to the proposal statement and problem statement like radio planning, spectrum forensics, regulatory policy. 1 minute. Data generated by radio planning, spectrum forensics, regulatory policy, sensor device agnostic, and sensing technique agnostic, and deployment model agnostic. Each of these use cases would likely involve a different type of user. To ensure this standard has flexible application, the user and user requirements are not defined. So coming to the proposed SCOS architecture, which is known as spectrum characterization and occupancy sensing. The purpose of this system is characterization and the assessment of the spectrum resources towards supporting its more efficient and effective use. To aim this, the standard under development defines functional entities that are part of SCOS architecture, their interface, and the structure of the messages that they can exchange, the possible interaction between, and the format of measuring data and metadata. So here you can see the diagram of SCOS, where it includes manager and clients and SCOS. So this is the process going on for providing different database in the form of signals. So it includes the sensor means sensor allows users, whether individual or other application, example an instance of manager, to interact with them via API, and optional provide a data distribution service to allow sensor data to flexibly transmitted to multiple users. And it also uses antenna, pre-selector, signal analyzer, and computer, which of these have different work to do in this process. So that the sensor software is required to provide wide status, advertise capabilities, provide onboard scheduler, be responsive to tasking, and package task results in a common metadata dot or data format. To support standard messaging protocols such as HTTPS and MQTT, the standard defines the sensor control service and object associated with the following endpoints like status, capability, schedule, and task. So you also see a block diagram which represent the transmission of sensor. So it is simplified block diagram of the sensor. Dashed lines represent the data or metadata information exchange, and solid lines represent the sensor data signal. So here it includes computer and signal analyzer, pre-selector. So and the manager is a software system that allows clients to interact with the distributed networks of sensor. So it includes operations, client request, distributed sensing acquisition, SCOS, owner control. And coming to the preliminary SCOS test bed implementation, the described idea has been implemented to provide a test bed where SCOS functionalities have been effectively tested and validated. The instrument used reported as a sensor in the standard draft and working as a sensor devices or national instrument product in 2901. The manager is implemented on notebook computer, and it along with the sensor is connected to a local area network which is known as LAN. The adapter sensors can scan frequency bands ranging from 70 MHz to 6 GHz, which is a wider range of bandwidth with a maximum instantial bandwidth of 56 MHz. So here you can see the diagrams related to the sensor, the process included in above information, and it is a graph shows the bandwidth of this signal, which is known as example for DVB-T signal acquired from USRP. Here frequency range from 610 MHz to 670 MHz, and this is the formula related to above the diagram, where the subscription J refers to the channel we are analyzing, and the function x of I is the indicator function of channel J at the ith test, meaning that is equal to 1 when the channel is classified as occupied, 0 otherwise, and n is the total number of tests in our 1000 cases. So here you can see the graph of performance of DVB-DT user detection at different power levels. So finally, coming to the conclusion, spectrum scarcity will be an increasing input factor in future communication paradigms, where an increasing range of spectrum users are cramped into a limited bandwidth. Better usage of currently unused spectrum of other will be vital to achieve the necessary bandwidth and capacity of delivery of new telecommunication services. It needs work still needs to be done on the IEEE 802.15.22,3 standard form before it can be fully adapted and used by the community. Testing with the practical implementation represent a crucial stage of development. So thank you.